Hey everybody, Mr. Covey here, and I'm going to do problems 13 through 17, 13 through the end in the review packet. Cool. Start out with a couple graphing ones. Okay. When you look at this one, remember this is the transformation one. This is the one where I'm thinking about the shifts. Yeah. That -3 on the bottom moves it right 3. That +1 on the outside moves it up 1. The times 4 is a stretch by 4. But that's not going to impact the graph quite as much. The important ones to think about are the right 3 and the up 1. Remember that your default asymptotes, your horizontal one is at y equals 0 and your vertical one is at x equals 0. And now I'm going to take those, and when the graph moves right 3, that's really only going to change the vertical asymptote, because the horizontal one, it's still the same. But when I move up 1, that's going to change the horizontal asymptote. It's really not going to change the vertical asymptote. Now that I have my asymptotes, I should write those down. My vertical asymptote's at x equals 3. Oops. My horizontal asymptote's at y equals 1. I need to try and sketch the graph. I know it's going to look something like this and this. That's what's nice about the transformation ones. But I'm going to plug in a couple x values to get a couple of extra points. I like to make a little table. And I'm going to pick maybe x equals 5 and maybe x equals 1. I'm just going to get a couple of points. I think that's good. I'm going to plug it in. And I'm just going to do it by hand. I think it's easier. 4 divided by 5 minus 3. 5 minus 3 is 2. 4 divided by 2 is 2. 2 plus 1 is 3. So I know a point on my graph is over 5, up 3. Oops. That yellow point's on my graph, which makes sense because I know it's got to look kind of like that. I'm going to plug in 1 now. 4 divided by 1 minus 3. 1 minus 3 is -2. 4 divided by -2 is -2. -2 plus 1 is -1. If you want to do that in your calculator, you can. I really think you guys can do that arithmetic without a calculator. Okay. What's the point in the graph? Over 1, down 1. It's right there. Cool. Which again matched up with what I thought it looked like, because it looks like that. My domain, I just have to think about the only time it gets messed up is at 3. I'm looking left to right. At x equals 3 is where it gets messed up. So I'm going to start at -infinity. I'm going to get messed up at 3. Then I'm going to start right back up at 3 and go to infinity. For range, I'm going to start at -infinity. I'm going to go up, 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 up. I'm going to get messed up at 1. But then I'm going to start back up at 1 and go up to infinity. Okay. For number 14, it's not one of the transformation ones. Instead, it's one of the ones where you have to factor. Okay? Sorry. Actually, let's not start by factoring. It's not one of the transformation ones. So instead, I'm just going to think about my little different rules for finding out different features of the graph. Okay? Let's start with the horizontal asymptote. Okay? So for these ones, you have to think about the degree of the numerator compared to the degree of the denominator. So this one is second degree over second degree. It's even heavy. So the horizontal asymptote, I look at the ratio of the leading coefficients. Excuse me. What numbers do I have out front? I have a 1 out front there and a 1 out front there. What's 1 divided by 1? It's 1. So my horizontal asymptote's at y equals 1. To find the vertical asymptotes, I'm going to set the denominator equal to 0. I'm going to solve that. Okay. I'm going to factor this. What multiplies to -12 adds to -1? -4 and +3. And so then what are the two solutions I get? I get out 4 and I get out -3. So this graph has 2 vertical asymptotes, one at 4 and one at -3. So I'm going to put those in. 4, we have a vertical asymptote. And at -3, we have a vertical asymptote. Next, I'm going to figure out the zeros. Remember, zeros is a fancy name for x-intercepts. I'm going to get that by setting the numerator equal to 0. Multiplies to 2 and adds to 3. 2 and 1. All about factoring here. I get two different solutions. I get -2 and I get -1. And those are my zeros, my x-intercepts. Sometimes it's nice to write them as points. -2, 0, -1, 0. Those are my x-intercepts. -2, 0, -1, 0. Those are my x-intercepts. Okay, cool. I'm all ready to do my domain and range. My domain gets messed up twice. It gets messed up at -3 and 4. So my domain is from -infinity to -3. Start back up at -3, go to 4. Start back up at 4, go to infinity. My range goes from -infinity, gets messed up at 1, picks back up at 1, and goes to infinity. Okay. The only thing I have left to do is get an idea of what this graph looks like, and I'm probably going to have to make a little table to do that, to get a couple extra x values. I definitely want to know what's going on over here, so maybe I'm going to pick an x value of 5. And I want to know what's going on over here, so I'm going to pick an x value maybe of -4. And I'm going to plug those into my equation. Go ahead and grab those x values, plug them in. 5 squared plus 3 times 5 plus 2 is 42. 42 on top, and a 5 squared minus 5 minus 12, -8 on bottom. You can type that in your calculator if you want to get a, if you want to get a decimal. It should be what? -5, a little more than -5. No, a little more than +5, sorry, that should be a +8 there. Cool. So a little more than +5. So I'm going to go over 5, and I'm going to go up a little more than 5, and I'm going to get a point up there. That's going to tell me this chunk of the graph probably looks like that, right? Because it can't cross those horizontal or vertical asymptotes. The middle chunk has to go through that green point, and that green point is probably going to look something like that. Why? Because it can't cross the pink line. It's got to hit those green points, so it must be below. I'm going to plug in -4 real quick. -4 squared is 16. 3 times -4 is -12. -12 plus 2 is -10. 16 minus 10 is 6 on top. Again, if you want to use a calculator, that's fine. Just arithmetic. -4 squared is 16. Minus -4 is +4. 16 plus 4 is 20. 20 minus 12 is 8. That gives me 3/4. So at -4, I have a point that's a little bit below the horizontal asymptote. Okay? I'm not positive what the graph looks like, but I'm going to guess that it looks like this. It's okay if we're wrong. We can only be so accurate in this because it's a little tricky. So it's possible maybe it looks a little different. But that's what I'm going to say my graph looks like. Okay, 16, 17, and 8, or 15, 16, and 17 are the equations. And the strategies we use are a little different here. For 15, it's just a fraction equal to a fraction. How do you solve a fraction equal to a fraction? You cross multiply. When you cross multiply here, you get 9 times x plus 4 equals 3 times x plus 8. And then just distribute and solve this equation. Okay, so 9x plus 36 equals 3x plus 24. Subtract the x's over the left side, numbers over the other side, divide both sides by 6, you get x equals -2. That's your solution. Cool? 16 is a trickier one. So now we have a fraction minus a fraction equals a fraction. For ones like this, the strategy we think is easiest is to multiply through the whole thing by the least common denominator of all three fractions. So if you look at all three fractions and you look at all the denominators and you say what's the smallest thing they all have in common, what's the smallest thing that contains them all, you get 5m. 5m contains all three denominators. That's the least common denominator. So I'm going to multiply through this whole thing by 5m. I'm going to get 5m times n plus 2 over 5m minus 1 times 5m over 5m equals 1 times 5m over m. I'm going to look at all my fractions and I'm going to simplify them. First one simplifies to m plus 2. Second one just simplifies to minus 1. Third one just simplifies to 5. Now I have a linear equation I can solve. I have m plus 1 equals 5, so m equals 4. Cool. For the last problem here, number 17, again, it's just a single fraction equal to a single fraction, so I'm going to cross multiply. This one's just going to be a little bit harder algebra. Yeah, so I'm cross multiplying. In order to solve this, I'm going to need to distribute both sides out. Okay, I'm going to need to get it all distributed out so I can move it all over to one side potentially and solve it from there. Okay, so when I FOIL out the left side, I get 2x squared minus 6. When I do the right side, I get x squared plus 2x minus 3x minus 6. Okay. I'm going to combine like terms on the right side. I'm going to get x squared minus x minus 6 equals 2x squared minus 6. This is a quadratic. I'm going to solve it by factoring it. So I'm going to move everything over to the same side. I'm going to move everything over to the left side. In order to do that, I'm going to subtract x squared, I'm going to add x, and I'm going to add 6 to both sides. Okay. 2x squared minus x squared just leaves me with x squared. Now I have a plus x. I had a minus 6, and now I added 6, so there's nothing left there. And I'm to this point. How do you solve this equation? You factor it. What type of factoring can you do on the left? You can take out a greatest common factor. What do they both have in common? X. What am I left with? X plus 1. Now that I have the equation factored, how do I solve it? I set each factor equals 0. I get x equals 0 and x equals negative 1 as my two solutions. Yep. Thanks for watching. That concludes this video.